Okay, in this video we are looking at chapter 10, section 4. Yes, we skipped over section 3, so relax, you didn't miss anything. There is no video for section 3. We jump right into section 4, so you need your St. James heading at the top, and then you write chapter 10, section 4, underline that in red, and you were doing triangles in this section, underline that in red, and this is part 1. There is 2 videos. There are 2 videos in chapter for section 4. Okay, a triangle, write this down, is a figure with 3 sides and 3 angles, and the symbol for a triangle is triangle, so that makes sense. Yes, write that down even though it seems obvious. Okay, all right, the angles of a triangle, okay, the sum of the measurements, or the measures of the angles of a triangle, is 180 degrees. So that means every angle in the triangle, you add them all up, you get 180 degrees. So that's what this little diagram shows you here. Angle A, the measurement of angle A, plus the measurement of angle B, plus the measurement of angle C, all equals 180 degrees. So they even color coded here for you. Angle A, measurement of angle A there, plus the measurement of angle C, plus the measurement of angle B will give you 180 degrees. You just add them all up. Okay? That is going to be important in a few minutes. Okay, so here we are. Now we're going to find a missing angle. So here I have this triangle here, and I give you 2 out of the 3 measurements. So we're looking for this angle right here. So I said all the angles need to add up to 180 degrees. So we'll write 40 degrees plus 70 degrees plus whatever x is has to equal 180 degrees. This same approach is what we use to find the missing angle. If it was straight or it was complementary or supplementary angles, we found the missing angle using this method. So we're going to set up this equation and solve. So first we have to add 40 degrees plus 70 degrees, and that gives us 110 degrees plus x equals 180 degrees. Again, I need to figure out, okay, what number does x have to be so that if you add 110 plus x, has to equal 180 degrees. So we will subtract 110, and we'll get x to equal 70 degrees. Okay, so the angle here, which is not, there's no name for it. It's not like angle A or angle B. So this angle right here is 70 degrees. Okay, it's that simple. Let's try another one. Here we go. Okay, in this case, we know for a fact this symbol right here means what? Means that it's 90 degrees. So again, everything still has to equal 180. So I'll do 90 degrees plus 25 degrees plus whatever C, in this case I labeled it C, equals 180 degrees. So we have to add 90 plus 25. So that gives us 115 degrees plus C equals 180 degrees. Yes, you're writing all this down all the time, always. Now we need to figure out, okay, what number does C have to be so that if you add it to 115, you get 180. So we'll subtract 115, subtract 115, and we'll get C equals what? Okay, well we have to borrow here. Make that a 7, make that a 10, and you get 65 degrees. So here we labeled, this is labeled angle C. So the measurement of angle C equals 65 degrees. Okay, so there's your answer. Okay, let's try another one. Here, we have an angle. They didn't label it for us, so I just put x usually. My default variable is going to be x. So again, we set up the problem. 20 degrees plus 130 degrees plus whatever x is has to equal 180 degrees. Okay, we first add 130 plus 120. That gives us 150 degrees plus x equals 180 degrees. I need to get a number so that if I add it to 150, I should get 180. So I need to get x by itself, which is why I subtract 150, subtract 150, okay? And x equals what? 30 degrees. Okay, again, they didn't label it for me, so x is 30 degrees. And that makes sense. That makes sense. Okay, now, there are two ways to classify triangles. Yes, you're writing all this down. You can classify triangles using their angles, their interior angles, or you can classify triangles using their sides. Yes, write all this down. Pause the video if you have to. Okay, so classifying triangles using angles, you have three names. You have acute triangle, and that's when all the angles are acute. They're all acute angles. So here's a triangle as an example. This is just a really small version. Okay, that's a little better. All the angles inside there are acute, so it's an acute triangle. Then we have right triangle, where, as you know, we've seen these triangles before. Okay, the one angle is a right triangle. It's a right angle. So you have one right angle inside the triangle. And then we have an obtuse triangle here, and that's because this angle right here, there is one obtuse angle. Obtuse, remember, meaning larger than 90 degrees. So the obtuse triangle will have one angle that is larger than 90 degrees. All of these triangles are described by looking at their angles, the angles inside the triangle. Okay. Another way to classify triangles is using the sides. So you have scalene triangle. That means there's no congruent sides. So my triangle would look like this. I would have one that's like this, and like that. And that's supposed to not be, none of them are supposed to be the same. Okay, so this is one side, this is two sides, and this is a third dimension. So maybe that's 3, 4, maybe it's a 3, 4, 5 triangle. 3 inches, 4 inches, 5 inches, and those little lines say this is one measurement, that's maybe 3 inches, this would be 4 inches, and this would be 5 inches. It just says that they are different measurements. Okay, isosceles triangle means there are at least two congruent sides. So here, my isosceles triangle would look like this. Two congruent sides. That means this side and this side are the same. So maybe they're both 4 inches, and the one on the bottom is 7 inches, I don't know, but two sides are the same. And then equilateral triangle means all sides, or the congruent means the same. Congruent means the same. So my equilateral triangle means this side plus and this side are all the same dimension. Maybe they're all 5 inches or 5 miles or 5 feet or whatever, but they're all the same, whatever it would be. They're all the same measurement. Okay, and those lines, these are tick marks. These lines tell you that they are the same measurement all the way around. Okay, and then I just have, here's the example of that. Sides, equilateral triangles, see these tick marks show that each side is exactly the same. Even if it's drawn kind of funny, always depend on these tick marks, because they show you here, these two sides are the same, and then this one is different because it has two. So this is an isosceles triangle because it has two sides are the same. The scalene triangle has no sides that are the same. And yes, feel free to print this little image out here. You can pause the video, print screen it, and then you can print it out. So then you have here's a picture of what it looks like for classifying triangles by their angles. This is hard to read, but acute angles, acute means everything less than 90 degrees, so this angle says 60 degrees. I know it's hard to read, so this angle says 60 degrees, and this angle says 60 degrees. So all those angles are less than 90 degrees, so that's an acute triangle. Okay, this one's obtuse because that says 124. I know it's hard to read these, so 124. That means it's an obtuse triangle because there's a very large triangle, and you know that little box says that's a right triangle. Good. Make sure you get all this down. Okay, so let's classify this triangle by its angles and by its sides. Okay, so here are my triangles, and I can see here already that this side and this side are the same, so this is an isosceles triangle. And I will admit I struggle spelling, so I always have to really check. Isosceles triangle, but we're doing it by its sides and by its angles. So the sides are the same, and angles, since there's no right angle here, I can't assume a right angle. Don't assume. Don't assume. Okay? Okay? We cannot assume that. So what we'll say is it's an isosceles, obtuse isosceles triangle. Obtuse because this looks like it's a little bit, just a little bit bigger than 90 degrees. So it's an obtuse isosceles triangle. I don't know why I just wrote it in two different colors, but anyway, obtuse isosceles triangle. Obtuse is for the angles, and then isosceles is for the sides. Okay, this one here, now I see that I'm given a right angle, so I know it's a right angle, but that's the angles, but what about the sides? Nothing is the same. See, 1, 2, 3. These are not the same. 1, 6, 8, and 10 inches are all different. So we have a right, okay, scalene triangle. So as you can see, this describes the angles. This describes the sides. And then you have triangles. So you want to have right scalene triangle. Okay? All right. Let's try another one. Here, I can see these are all the same. So that's definitely equilateral triangle. And these look very small. So we can say acute because it's less than 90 degrees, acute equilateral triangle. Acute equilateral triangle. Okay, so that's how you would classify triangles with their by their angles and by their sides. All right, problems for next class. All right, what you're going to do is you're going to find the missing angle. So here we're looking for the measurement of angle H, and then classify this triangle. Okay, classify this triangle. All right, obviously you'll classify this triangle using the angles, because the sides aren't given to us. Angles, okay? And they're all like that, as you can see. I give you 3 of them. This one, again, you want to find the measurement of angle U. It's labeled as U here in this case. You're looking for this one right here. And again, you're going to classify using just the angles because the side information isn't given to us. And then you're finding the measurement for angle J right here. Okay, that's a J. And again, you're just using the angles as a way to classify these triangles because the sides are not given to you. So have these done before next class. See you next class.